The last section of notes. This starts on page 18, page 18 in your packet. Should you write small? No, I think you can write a normal size today. Am I absolutely positive? Yes. Yes, I am. Okay, so everything that we've done so far all has to do with linear relationships. So we found the line of best fit, we found the slope, we found R, we found R squared, we found the standard deviation, we looked at residual plots. So we've analyzed the data when it's linear. So what do you do if the data is not linear? You know, how do you find a curve to fit it? It's a lot harder than it sounds like. The least squares regression line is a very accurate and reliable method. So what we're going to do today is we're going to take data that's not linear, and then we're going to transform it to make it linear. I've been told that you guys have done this in physics before, maybe. It's not the same as what you did in physics, so it's different. It's a little bit harder, actually. So basically what we're going to do is we're going to look at data, find the best transformation. Today is a lot of calculator stuff. Okay, a lot of calculator. First thing that I want you to do is put these lists into your calculator. I know, we don't agree on the bus.
Wait, who did? What are you talking about? What are you doing?
Okay. Do we have this in list 1 and this in list 2?
Yes.
Okay. So I'm already going to tell you, well, look at a scatter plot. I don't know what the scatter plot looks like. Look at a scatter plot. I'm going to assume it's not linear.
36.
Let me see your scatter plot when you have it. Yeah, it looks a little curved. Looks like it could be curved. How can we verify that that is curved? Look at the residual plot. So find that next. Find the residual plot for this data set, please. What do we have to do before we find the residual plot?
Oh, this, like the line, right?
You have to do the linear regression. So before you even look at the scatter plot, go and do second calc, or go stat calc, go down to number 8, do your regression, then find the regression for the residual plot. Once you have a residual plot, compare it to the person next to you and make sure you guys are looking at the same thing.
Scroll down to edit. Scroll down to 6.
Here, and it's
Bottom.
I know, but that's
Second.
it's in 9.
That seems looks the same.
As the white
Gotcha.
What did you get?
Okay. The residual plot should be clearly curved. Like it does not look random. It looks parabolic.
Yes.
Like shaped up. Parabola open up. Okay. That's a curve. Okay. So we would not fit a line to this data because that would not be appropriate. The data is curved. So what we want to do is we want to transform either x or y or both and try to make the data more linear. So what I want you to do now is go to the blank calculator screen, and I want you to store these lists. So I want you to put the square root of y in list 3. The way that you do that is square root of list 2, so square root of y, and then store it in list 3. Then in list 4, I want you to put the log of y. So you do the same thing, log of L2, so log of y, and store it in list 4. And then I want you to put the log of x in list 5. So log of L1, and put that in list 5. Okay, did we get that far? Okay, I'm moving on. Hopefully that's okay. Okay, so that was the scatter plot that you were looking at. And that's a curve. Okay, so here's the process for transforming data. First thing is you look at a scatter plot, which we just did, and this is in your notes, so just look at your notes. You look at your scatter plot. So we did that and we determined, maybe it looks linear. Non-linear, I mean. Then we looked at the residual plot, we saw it was curved. So that tells us we need to do a transformation. Once you do once you decide that you need to do a transformation, you transform either x or y or both using what's called the ladder of powers. For me personally, I transform one or the other. So I never transform both x and y at the same time, because then you don't know which transformation is having what effect. Does that make sense? So if I change them both at the same time, I don't know which one is, I don't know what they're doing. So I personally normally transform x, but it's x, y, or both. This is the ladder of powers. So the way that this works is that you're going to have a curve that looks like either section 1, 2, 3, or 4. So like your data might look like 1. So maybe you have points like this. Because it looks like 1, you either take the power of x up or the power of y up. So for example, you might do like x squared or x cubed or y squared or y cubed or some y to the 4th, something like that. If your data looks like curve 3, like something like that, you either take y down, x down, or both. So examples of down are the reciprocal, natural log, common log, square root, cube root. And all of these examples are written on the table that you guys have. So there should be a table. That one.
What do you mean by you transform them? You just take every data point?
Yep. Yeah, so that's what it means. If I decide to take the natural log of y, I would take the natural log of every single observation.
Not the residuals? Just
No. So this is where we start, is x and y to the first power. So this is going higher to the second and third power, that's going lower. So square root, cube root, log, reciprocal, natural log. Few things to beware of is you need to keep in mind the domain of the function that you're using. So for example, you can only take the square root of positive numbers. So if your data set had negative numbers, you wouldn't choose the square root. The two that you're going to forget are these two. Log and reciprocal is only positive numbers. So numbers greater than 0. If your data set has zeros, you cannot do the log or the reciprocal. You cannot take the log or the reciprocal of 0. The first one in your homework is like that. The first or the second one. There's one in your homework like that, where the data set has 0. So you would not choose log or reciprocal. In that case, you would choose the square root or the cube root or something. Okay, so you transform your data. And then you look at a new scatter plot of your new data. And then you do your least squares regression line. And then you look at a residual plot. And then you determine, okay, is my data more linear? Based on my new scatter plot and my new residual plot, does the data look more linear? If it does, then that is your transformation. If it doesn't, if it still looks like a curve, then you got to go back and do that all over again. And then you got to solve for y, and then plot again. So we're just going to do an example. Does that sound good? Okay. So X versus Y we already did. This is the data set that you guys still have in your calculator. So like the bottom of page 18, you're writing nothing on. Like I don't have anything for you to write there. So if you want to write this, that's fine. That's what X versus Y looked like, and that's the correlation coefficient. So the first transformation that I'm suggesting is X versus the square root of Y. So the first thing that you're going to do is look at that scatter plot. So X is in list 1, the square root of Y is in list 3. So what you want to do right now is do a scatter plot of list 1 versus list 3. And see, did this transformation make your data set more linear? Does the data set look more linear? Yeah. Maybe. Okay, calculate an R value, just to see. See, does the relationship get any stronger? I think that's what you should get. Is that the scatter plot you guys were looking at?
Yeah.
And you get an R value of 0.9889? Okay. So maybe that's a good transformation. We don't know if it's best or not, so we gotta try a few more. So now I want you to try the transformation of X versus log of Y. So this is list 1 versus list 4. So now you gotta go do the scatter plot of list 1 versus list 4 and then calculate an R value again. I think I got that. Are you all with me currently? Have I lost anyone? No. Okay. So that third scatter plot, that looks curved. And our R value actually decreased from what it was originally to that transformation. So that tells us that this is not a good transformation. It didn't make the data more linear, and R didn't increase at all, so we're not going to use that one. Between our first option, X versus Y, and X versus the square root of Y, which one is better? Which one is more linear? Second one, right? So we're not going to do that one. We have one more that we're going to try. We're going to try log of X versus Y. This time I want you to transform X. Log of X is in list 5, and then Y is in list 2. So now you have to look at a scatter plot of list 5 versus list 2. So do that, please. And then calculate an R value also. I think I got that one. That scatter plot and that R value.
Yes.
Okay. Scatter plot does not look linear, and the R value decreased again. So this is not what we would do. Do you guys get the process?
Yeah.
Okay. Do we need to keep doing those two? Can we just stop where we are? Okay. So we're going to choose this transformation. Look at our residual plot just for fun. Just to make sure that the residual plot looks random. What do you have to make sure you do first? You have to do the regression. Because remember, the last regression you did was this one, which is not the correct regression. So do that regression. So do the regression between list 1 and list 3, which is X versus root Y. We already looked at the scatter plot and the R value, so now look at the residual plot. That I do not have up here, so you're going to have to compare that to the person next to you to make sure that you guys agree. Did you just show that to Air next to you? I thought it was funny. I wasn't making fun of you. I got a good chuckle out of it.
I'm sorry, so if you're listening to these second languages, for which list is that?
It's the one that you use
Oh wait, we're making the residual. Wait,
How do you make sure that
Yeah,
it's,
so here,
that you're taking
for the second one, we did X residual with Y. So X is in list 1.
even Y.
wait, are you taking the residual
that's how
of this?
yeah. No, I know, but like how do you make sure that
So you have to do the linear regression of 1 and 3. And then, do residual. Y is.
Okay. Do we all have a residual plot that looks like the person next to us?
No.
No.
More or less.
Oh, I'm just confused. How do you make sure that you're doing the residual of that of L1 and L3, not L1 and L2?
It does the last linear regression.
Yeah, but you have to.
So whatever your last regression was, it calculates that.
Right, you're plotting L3.
Or that set of the residual.
Residual of L3. You have, okay, so you have to go to whatever you store the residual.
The residual plot should be L1 versus the residual list. But your residual list comes from the last regression that you did. So did you guys do the regression between L1 and L3?
Yeah.
Okay, so once you do that, then do the plot of L1 versus the residual list.
Leo, did you go to the school of the New York Times?
Forget the name of the damage.
Okay. Does our residual plot look random?
Yeah.
Oh, sure.
Yeah. Depends
This is running really hard.
Oh
What's a good?
Alright, what's over under on when you stop?
In my personal opinion,
128.
guys, I know that it's hilarious that Leo went to the, which I don't even know why it's funny because it's not. So can we maybe focus? Awesome. The residual plot to me, I don't think it looks super random personally, but in the interest of time, we're just gonna keep going. Okay. Okay. So we are now through step 6. We determined that x versus root y is our acceptable transformation. So what I want you to do right now is go back, do the regression between x and root y, and find the equation. So I need to know what the equation is. So when you have it, tell me what A and B are. Wait, is this A or
is negative point
0.339?
yeah.
3, 4.
Okay.
B is
1.07.
Why is this such a struggle, guy? Just reading numbers off the
Because we
calculator.
all want to make sure we're not wrong.
yeah.
You're going to be wrong. We just need to accept it. That's just life. You're going to be wrong. I'm wrong at least 400 times a day. So.
We know
That's a lot.
You better be glad that I have high self-esteem and that did not hurt me.
That's why.
I had a student earlier today tell me, "You're kind of smart, Miss Button." You're kind of smart.
Whatever doesn't kill you makes you stronger.
6 to 9%.
Okay, anyway. So, writing this equation. This is the equation between x and root y, not between x and y. So your equation would be root y equals a plus bx. So negative 0.34 plus 1.07x.
But we still put the hat on the.
Oh, it's like a house.
Okay, but I want y equals. I don't want root y, so you're going to have to square both sides. So we're going to get y hat equals negative 0.34 plus 1.07x squared. So this would be our equation that will fit the curve.
Will we ever have to square out those values?
No. Yeah, no. Don't actually square them. Okay. Not too bad? few things I want to remind you of is if you decide to use log instead. So let's say we got, I'm making up numbers, okay? But let's say we did log of y equals 2 plus 4x. How do you transform out of that? Throwback.
X to the 2 plus 4x equals 1.
Wait, x to the 2 plus...
Or something.
like a power.
Yes.
So we don't remember logs.
It's 10 plus 4x equals
Yeah.
You are very determined about it.
So-
Right.
The base is
We
10.
got base 10.
So this is the base, that's the exponent. So you get y equals 10 to the power 2 plus 4x.
It's been all.
Okay. Oh, now I'm going to confuse us more. What happens if I use the natural log?
Oh no.
E. So you get y equals e to the power 2 plus 4x.
I got a 24% on this unit test last year, so let's.
Okay. Any questions about transforming data? No. Okay. Wonderful.
Are you still recording this?
Yes, I am. Sorry, can't get it back now.
There's this little nice thing called editing.
You think Miss Button's gonna spend the time?
Thank you. Guys, stop talking. So here's how you're going to see a question like this, a transformation question. Is I will give you a data set, and I will say, is the data set linear? And then you're going to tell me no. And one of two things is going to occur. I'm going to say, suggest a transformation. So all that means is tell me a transformation that is logical based on the ladder of powers. Or the question will be, I'm suggesting these two transformations. Which one is better? Okay. So, for example, first type of question I could ask you. I might give you a data set. Whoa. Forgot how to write axes today. I gotta think about this. Okay. Woo. Okay, I could give you a data set like this and say suggest a transformation. Okay, I mean it to be curved. Okay, it's curved now. Okay, so draw yourself the ladder of powers, which is like this. Is this going to be like quadrant 1, 2, 3, or 4? 2. Quadrant 2, right? So here's quadrant 2. This is a negative x, so that means you take the value of x down. This is positive y, so you take the value of y up. Either one of those two will work. So suggest a transformation for me.
Y squared.
Okay, y squared. That's good. That works. What else?
Y cubed.
Square root of x. That's good. Y cubed. That works. Cube root of x. Log of x, you could do reciprocal of x, any of those. Please remember, if you decide to do log or reciprocal, though, you got to make sure that there are no zeros in your data set. That's the first type of question I could ask you. Second type of question I could ask you is, I have that data set, and I'm looking at either the square root of x as my transformation or y squared. Which one's better? What would you do if you were going to answer that question? It's the first thing that you would do.
Enter your data set.
Okay, we entered the data set.
You're welcome.
The scatter plot.
Where?
Which scatter plot?
Both.
Okay, so you're going to look at a scatter plot of both. What are you looking for? Since when does the R value come on a scatter plot? When I'm looking at the scatter plot, what am I looking for? Yeah, if it's linear. What else are you going to look at besides the scatter plot?
Regression.
R. So you're going to look at R for both transformations. What else are you going to look at? The residual plot. So you're going to look at all three of these things for both transformations and use all three pieces of information to determine which regression or which transformation is more linear. Okay?
You don't ever have to do both of them, right? Like, do you have to use the square root of x and y squared and do both transformations and then compare which one?
It depends on if they tell you to do that or not.
Okay.
So it'll be clear. So you also might have to do square root of x and y squared at the same time, is what Kate is saying. So the biggest issue with this is you guys have to remember what is in each list in your calculator. That's what's going to throw you off. On your homework that is due on Monday, the last problem, I think, gives you like 5 transformations and it says which one is best. I want this information for each transformation. I want a scatter plot and R and a residual plot. I don't want you to do any of them by hand though. Do them all on the calculator and just sketch them out for me so I know what you're looking at. Is that fair? Okay. Questions on transformations before we go on?
When you're looking at the two R's, do you want to pick the one that's closer to 1?
The one that's stronger. So closer to 1 or -1. Okay. Next thing that we're going to talk about. Okay, we also need to be able to read Minitab output when they do regression that is not linear. So there are 2 other types of Minitab output, polynomial output and nonlinear output. So this is on page 19. Okay, so this is it says a small coffee company is attempting to set the price for its regular coffee so that their profit is maximized. They manipulate the price in 5-cent increments at different locations and record the profit. So you guys can see this is just a normal regression equation. Like this up here, which we've done before. You have to be able to read that this is the slope of the y-intercept, that that's the standard deviation, that that's your r-squared value. Is there anything else you need to be able to read from here? If I'm asking, the answer is probably yes. So what else am I expecting you to know?
The SSR is on there. The residual error.
Yeah, those 2, and then the SS. So that number is SS resid, the residual sum of squares. That number is the SSTO, the total sum of squares. Okay, so that's the regression that we got. Yeah, that's what I just said. Okay, this is the scatter plot of the data. The one on the left is a scatter plot of the original data fit to a least squares regression line. What's on the right? Residual plot. Based on the scatter plot and the residual plot, was our line a good fit? No. Okay, this is on the next page. So this is on page 20. This is a different type of output, but it's read very similarly. You see this equation at the top? So what is different is that you have an x now, which is price, and then you have x squared, price squared. So this is polynomial regression. They fit a quadratic to the data. You also need to be able to read it from here. So the number next to constant means that it doesn't have an x. The number next to price is the coefficient on price. The number next to price squared is the coefficient on price squared. So the coefficient on x squared. That's all you need to be able to read from there. So that should be pretty clear. This is the curve now that was fit to the data and the residual plot. Looks better or worse than the linear regression that we did? Should be clearly obvious, better. Okay. That was section 4. Woo! Not too bad?